Hey everyone, welcome to the stream. I hope you're doing good tonight. I will give you just a few seconds for everyone to join. I'm really glad to be here. So, if you don't know me, I'm Mr. Elliptic. I'm a full-time indie game developer. And I also have a YouTube channel on which you're viewing the stream right now. I'm working on Dashpong, a local multiplayer game. It's the game you saw during the countdown. And today I'm here to make a game, at least start making a game, because I have about 2 hours, so I don't think it's enough for me to make a game. But we'll start working on something for the GoGodot Jam too. And I guess that if you're joining, you're aware of the GoGodot Jam 2. If not, you can check it out. There are tons of events, and this is one of them. The jam has already started with the theme Energy Source, but you can still join. So please join if you want. You still have about 5 days, and in 5 days you can make something. Hi Johnson, welcome to the stream. So yeah, you can join. Let me give you the link, and then we'll start. So, as you heard, the theme is energy source, and I have an idea of what I can make. It's a 3D game, and I think the best for me is to show you on the tablet. I will do a bit of a brainstorm session just for you to know what I want to do, and then we'll start working on it in Godot, of course. I hope you can hear me well. The music is not too loud or too quiet. Don't hesitate to tell me if this is the case, okay? And also, I hope that you're joining the jam, and if you are, please tell me in the chat. Please tell me if you're working on something, and maybe tell me a bit about your game. Okay, so let me switch to the tablet. Sorry, it's going to be a bit bright, but I can't put it in dark mode. So let me show you my idea. I want to work on a 3D game where you have an environment. So let's say that we have something like, maybe this is a bit small. We have something like a path like this. Okay, maybe with some things that you need to avoid. So this is a pendulum. This is a big pendulum that you need to avoid. Okay. And you have a cart. It's a physics-based cart, and you'll see we'll make something pretty cool. We'll make something like a hoverboard. I made a video about that, how to make a physics-based hoverboard, and you'll see it's pretty cool. I think we can make something interesting with that. So you have this like cart hoverboard thingy, and you're controlling a character, a third-person controller, okay? And your goal is to grab the trash that is scattered around the world, and you want to bring it to the end of the world, okay? Let's say that this is the end of the world. Oops, it's not what I want. Let's say that this is the end of the world. I think Whisk, you can't send a link, I guess. YouTube will not allow you to send a link. So if you want, you can send the name of the project or something, but you can't send a link. So this is the finish. Okay, let's say this is the finish. And you want to bring the cart with you. And oops, and with the trash that you put on the cart. Okay, you have to finish with the trash on your cart, and those will be counted to create a score or something. I don't really know right now. So basically what you have to do is you have to go there, take that, put it on the cart, and then push the cart. Of course, you have to avoid this thing, you have to avoid the hole that is there, so you have to go there, and you have to go to the end of the cart, the end of the world. So it's pretty simple. It's using the idea of energy source in terms of you have to get the trash to get because it's your energy source. And I think it can be cool. We can make a cool environment, and the interactions will be interesting. So that's it. And now we'll move on to Godot and make that. Let me just publish something somewhere. Okay. It's not published, but I was trying to send a GIF. Oh, okay. Yeah, you can't. I'm sorry, but you can't. I can't. Like, it's the YouTube policy. I can't change that. They are being very, very careful now with links and stuff like this, and they will remove it. whatever you're trying to do. Okay, so let's start. I think the first thing we can do is create the character. Okay, let's create a character. It's going to be a kinematic body. I'm gonna call it player. I can't type already. I'm gonna name it player. Create a new folder. Scenes. So clearly, I would not advise working on a physics body. Sorry, it's not what I wanted to say. I would clearly not advise on working in a 3D game for a game jam, unless you know what you're doing, first of all, and of course if you have the time for it. Like as I told you, you still have about 5 days. It can be short. Let's be honest, 5 days is not a lot. So working on a 3D game can be a risk. But I'm a host. I don't really care about winning. I don't even think I can actually win something. I'm not even sure I can participate in the jam. But it's fine because I just do it for the fun. Okay, so this is way too big. So what I'm doing right now is I'm creating my player. Hello Anons, welcome to the stream. I'm working on the player, and it's gonna be a simple mesh. Okay, a simple capsule at first. You really need to start simple. I think that's the biggest thing to remember when making a game, especially for a game jam, is you want to start with something super simple, make sure that it works, and then you do something else, and then you improve on it, you add stuff, you add juice, whatever, but first you start simple. Okay, so we have the player. Pretty cool. One thing that we can do is we can duplicate this mesh instance and add a cube mesh. I'm going to use that as the eyes, if you want. The idea is that right now it's just a capsule, so I can't really see my player. Like, I can't really see where he is, right? So first of all, let me change the material just to see something. So I'm gonna use the hey Redefine, good to see you. I'm gonna use that to see that it's the front of the player. Okay. I want something bigger. Okay. So these are the eyes. Let's put them somewhere like this. Okay. I'm not trying to copy a famous game, so please be gentle with me. Okay. We have an amazing player, and he's facing forward in the -z direction. Okay. It's the usual forward direction in Godot, so I try to stick to that when I work on a character. I think it's just easier that way. So okay, we have that. We are going to need a camera for sure, so I'm just gonna bring out the camera right now using the 2 viewports to see what the camera is seeing. I'm gonna make the FOV a bit bigger, maybe. And now I can place my camera. So what I want is some sort of top-down view from quite high, I think. And we can adjust that after, of course. Seems kind of sus. No, absolutely not. Absolutely not. I don't know what you're talking about. Okay, so let's add a script and we will work on the script. I'm just gonna create a new folder. I'm usually trying to do that. I'm usually trying to have a folder for scenes and a folder for scripts. That way it's a bit clearer, but you can do as you want. Hello, cheers from Portugal. Wow, nice. Good to see you. Sup, Mr. Elliptic. Hello, non-unknown. Good to see you there. Where are you guys watching from? I'm from France. Cool to see people from all around the world. That's the beauty of online communities like this. I love it. Like, we have people from all around the world. That's pretty cool. So welcome everyone. I hope you will enjoy this little stream. So it's a kinematic body. We are going to define some variables at first. So velocity. I hope I won't have too many problems, because Windows is giving me a lot of troubles recently with USB devices, and it's like disconnecting my devices all the time, so I hope it's going to be fine. The worst that can happen is that my camera will freeze and I will lose control, but that's okay. Nope, it isn't Mr. Elliptic, it's fucking Mr. Epic. Thanks, non-unknown. I love your enthusiasm, that's cool. Okay, guys, velocity, what do we want? We want also speed, I guess. At first I have no idea, like, what is the speed that we want to use, but we'll see that. We'll probably need some jump, I don't know, and that's it for now. We'll start that at 0 to make sure. I like to initialize things. And we need to do something first to be sure that the camera is going to follow us. So I'm going to grab the camera transform. So on ready var, camera transform. I'm grabbing the camera and origin. I'm grabbing the camera transform, okay? Because right now the camera is attached to us, so it will move exactly as we do. But I don't really want that. I want a bit more control on the camera. So what I will do, you will see, it's pretty cool. In Godot you can do that. You can do you can go camera, you grab the camera and you go set as top level true. With that, it will ignore all the transform of the parent. And I will show you that real quick. So to show you that, I will create a test scene. I will just put a mesh that is going to be a floor mesh instance. I can change the view to one viewport only. We don't need that much. Let's let it be the floor. Let's create a cube mesh. I know I can use a CSG, but I want something simple. No, that's not what I want to say. I want something with more control over, and CSGs are bad for performance, but I think we can use them later. Let's make that a bit darker for your eyes. USB issues, or really, happens to be two. I thought it was my hardware. Seems I'm not alone. Well, I guess it's not my hardware, because when I was using Windows 10, I think it was working fine, and I still have a Linux distribution. So I went back to my Linux distribution, and I have no problem with USB. So I guess it's a Windows thing. But the thing is, because it's the root USB thing that has problem, like everything gets disconnected. Everything. So like my camera, my mouse, my keyboard, it's a pain. It's really a pain. And it happens a lot, at least once per stream. Because I'm streaming on Twitch usually, and it happens once a stream, so it's pretty terrible. Tree mesh static body, that way we have a floor, and we can put our player right there. So let's put it here. Okay. We'll just run that to see that it works correctly, and we have the player, and that's fine. Okay, so I'm gonna make the player move first, and then I'm gonna show you why. I'm gonna show you that the camera is detached from the player. So let's go to project settings, to input map, and I'm going to add some inputs. And Linux wins again. Yeah, true. The only thing that is not allowing me to use Linux is the fact that I need to do some VR development, and I can't do that with the Oculus Quest on Linux for now. And also minor things, like I have many games installed for Windows and I don't really want to put them on Linux. But other than that, I could use Linux all the time. I was using Linux as my as my daily driver before, and it was working really good. Really good. Godot is made on Linux, yes. But it was working better on Linux, to be honest. The performance were much better, but yeah. Sounds as if the hub is turning off. You can check properties in Device Manager. Try disabling the checkbox telling Windows it can power it off. I did that already, and unfortunately it continues. And I think that you can hear it because you have my desktop audio. I think that you can hear from time to time you hear the USB thing of Windows. But right now I still have everything connected, so it's fine. But it's just doing weird stuff. Why not? I guess not unknown, and I guess I can't do that because I'm using I'm trying to deploy to the Quest using the native libs, and I don't think we have what is needed for Linux, but I might be wrong. So I don't know. Okay, let's go. I want left, right, forward, and backward. I also want jump. So I'm gonna set up the Deadzone as 0.1 for every one of them because I want to use a joypad, a gamepad if you want. This one I'm going to keep it at 0.5 because it's just going to be a button. So left, joy axis, left stick left, right, joy axis left stick right, forward, joy axis left stick up, and finally, joy axis left stick down. For jump, I'm going to use a joy axis also. I'm going to use R2. No, not for jump. For jump, I'm going to use joy button. I'm going to use A. I think people usually use A. My issues are new since the last Windows update. Maybe that's that. You can check, and you can check the events on Windows to see what's wrong, but I couldn't figure it out. Like, I don't know. And in my case, I just need to go to the Device Manager, disable the root USB thing, enable it again, and it works. So I don't know. It's weird. Maybe I have a USB device that is causing me some trouble. Maybe I have a weird USB device that is drawing too much power or something. I don't know. And I'm too lazy to spend hours finding why. I will just switch back to Linux and it will be good. So we have all of that. Let me just add some keyboard controls in case people want to use keyboards. So key, I'm gonna use A for left. I'm also gonna use Q for French keyboards. For right, I'm going to use D. Forward, I'm going to use Z, but also W. Backward, I'm going to use S. And finally, jump, not a physical key, I'm going to use space. Alright, I think we have everything that we need for now. So let's start with that, and we'll add more in the future. So we'll need two things. We'll need the process function, and we'll also need the physics process, because we are going to, and I can already put it, we're going to move and slide. Move and, no, not move and collide, move and slide. So the velocity is going to be the velocity we defined. Up direction, it's going to be vector 3 dot up. Stop on slope, we want to stop on slope. Max slides 4. The max angle 785,389. Okay. And infinite inertia, we don't want that. But I will show you why we don't want that. I will make it to true first. And that's it. Oh, it's not a vector 2, sorry. Vector 3, of course. My velocity is a vector 3. I need to build a new computer soon. I think I will just forget Windows and just install Steam. Yeah. I mean, for if you're a bit techy, you can go with Linux without too much problem, but you have to understand that you can have some problems. It's not completely streamlined yet. From time to time, things will not work, and proprietary devices will not work. Like you will buy a device and it will not be supported, but it gets better. It's better. It's way better than before. And that's a good point, I think. Okay, so we have our velocity right now. It's not going to do anything because we are not changing the velocity. So one thing we can do, we can define a direction vector. It's going to be a 2D vector. It's going to be a 2D vector because I won't care about the y-axis at first. So what I'm going to do, I'm going to do dir.x input. Can you please, yes, get action strength. We are going to go right minus left. This will give us a value between -1 and 1. -1 will be left and 1 will be right. So this will give us a analog value with the controller, but the good thing is it will also give us a value with the keyboard. Get action strength will work with the keyboard. So with this line you support both the joystick and the keyboard, which is pretty good. Hello, what are we creating? I'm creating a game for the GoGodot Jam 2 with the theme Energy Source. And the goal of the game is that you have a small character that has to collect trash and put it on his little cart to bring it to the end of the level, because it's using the trash as energy source. Hey Quantum Code, good to see you. You switched from Twitch to YouTube. I'm streaming on YouTube because this is a special event for the GoGodot Jam. But I will be streaming on Twitch tomorrow, as always. And I can't stream on both platforms at once because I'm an affiliate now on Twitch, and I'm not allowed to do that, unfortunately. So we can do the same thing with dir.y, and you'll see it's pretty simple. So we are going to go forward minus backward. Okay, I think this will not be right because we're going in -z, but we can change that later, so that's fine. Completely random, I found out that Godot has add user signal function. I wonder if the signal shows up in the editor. You wonder if this add user signal function. I don't know. Honestly. Hobo Simulator, gotcha. Yeah, exactly. I think I will name the game like Trashland or something like this. But Hobo Simulator is also good. Maybe it's not very friendly for hobo people, but yeah, you get the point. Okay, so that's cool. How are you going? How is your game going, Quantum? Are you still working on it? I didn't catch your stream recently. I don't know if you streamed recently. I just started halfway through this Jam 2. My idea is pigeon jumping over electricity on a telephone wire survival game. Wow, this sounds super cool. Frydev, like the idea. I love the pitch. Like there's a pigeon jumping over electricity. It's really cool. I like it. So what should we do now? We should change the velocity. So we are going to affect the velocity in the... where's my player? It's there. It's really small. I forgot. We're going to change the velocity in the X direction and in the Z direction, okay? Because we don't want to touch Y for now. So velocity.x is equal to lerp velocity.x. I'm already lerping the velocity because it's going to be smoother, so I prefer that. We want to do direction.x times the speed, and for that we want to use accel. So let's define our acceleration. Our acceleration is going to be something like 0.4, I think. And we can also define friction. And friction is going to be a bit smaller, like 0.1. Should be fine. So we need to do something first. We need to do if direction is different than vector2.0. So this is not the funniest part, but you'll see in just a few minutes we'll have a third-person character controller, and then we'll move on to something more interesting maybe. So what we want to do here, we want to accelerate because the input is different from 0. But in the other case, we want to go back to 0, and we want to do that at the friction speed. Okay? And we can do the same thing, but for Y this time. So, this is where we have to be careful. We want to change the Z velocity, okay? Z velocity, but we're going to use direction.y because direction is a 2D vector, so it doesn't have a Z direction. Okay? And with that, we are moving. So if I'm not mistaken, right now, we should be able to go left and right, and the up and down is inversed. This is because we are moving in the -z direction. So one thing that we can do is we can just put a minus here, or you can change that. You can swap those to change the sign of the vector, but it's basically the same thing. And so if we test, we can go up and down, and we can go left and right. Perfect. And we can go in circle. Wow, cool. So one thing that we can see already, basically our character is strafing. So when you go to the left, it's going sideways, but it's not looking to the left. So we can change that. And also, as we can see, the camera is not following us. So we can change both of those things. So the first thing that we can do is, inside the process function, we can go camera.globalTransform is equal to our global transform. Okay? Remember that even though the camera is our child, okay, it's the child of the player, we set it as top level. So it's ignoring the transform. So we can use that, global transform. And what we can do is we can add the original camera transform, the one we defined here. And we can actually use the transform and not just the origin. No, I don't want to use the transform. I will use the origin actually, because otherwise I will also change the rotation, and I don't want that. So I can already see a problem with that. When we are jumping, we're going to jump with the camera. The camera is going to jump with us, but we can change that later, okay? Okay, pretty cool. We can also do something. We can add a jump. So let's check if we are jumping. So if input dot is action just pressed, that way if we keep it pressed, it's not going to trigger multiple times. We are going to change the velocity in Y. So Y in 3D is going up and down. And we are going to use the jump force that we defined earlier. We'll need to check if the jump force is good, but that's okay. We also need to check if we're on the floor. This is a function of a kinematic body. We can check with this function if we're touching the floor or not. So this is pretty cool, and this will be updated every time we use move and slide. So right now it will work. We can check it will work, but it will actually not work. It will actually not work. And why is that? We defined jump, right? Oh, it will not work because we are not using the gravity. So we need to define a gravity force, because right now we are not. Take a look at the test scene. Right now we are not touching the floor, as you can see. And basically, because I'm not applying gravity, well, we are not touching the floor. So is on floor is giving us false. So we can add some gravity. Gravity is going to be a float. And I don't know. Maybe start with 100. And basically, each time we are in the process function, we want to apply gravity. So I think it's plus to go downward. No, it's minus. It's in 2D that it's the opposite. So you want to do gravity times delta, because we're doing that every frame. Let's check. Okay, so now we are touching the floor. We are moving. It's fine. And we can jump. Okay, pretty cool. It's starting to look like something. I think that's fine. So something else that we can do is we can rotate. We can rotate based on where we are right now. Where we are heading. So for that we can use our direction. We have a direction input vector, and we can use this one to rotate left and right. So let's use that. Let's do rotation. Basically, we will just rotate the body. Rotation.y. And I'm going to use lerb first, but I know that it won't work. With angles, it won't work. But I want to show you something. So we want to lerb the rotation y. And to know the angle that we want to use, we want to get the angle of the direction. And we want to offset that, I think. Because it will not be right, but we'll see how much we need to offset. We'll see that in just a second. And we'll use some values for the loop. So there will be two things, I think. Let's check. Okay, so first of all, what you can see is that even though I'm going left, I'm pointing towards the ground. So I need to offset that by a quarter. I need to offset that by a quarter. So I need to go. So in a circle, pi is the 2 pi is the full circle. So pi is half the circle. So we want to remove pi over 2. I think that's it. I think it should work. And now it should be in the right direction. So right, bottom. Oops, I failed. it's not big enough. So forward, right, left, and down. So as you can see, there's a problem right there. So it's fine when you're on the right, but when you go towards the left, at some point, the lerp is going to do something weird. And this is because you're trying to lerp an angle, and the lerp function will try to go in the shortest route, or maybe not. I don't remember, but the problem is, it won't really work with angles, but we are lucky with Godot because we have lerp angle. It's basically the same function, but look at it. It's cool. Now it works. You provide the same thing, but now it will work correctly with angles. So that's pretty cool. So if you have this problem in the future, remember that it's just a matter of using lerp angle instead of lerp. So right now, I think we have what we need. So that's pretty cool. I think we have what we need. The only thing I want to change is that right now, if you saw, right now, when I jump, the camera is jumping with me, and I don't know, I don't think like it's a good idea. It doesn't really feel like I'm jumping, so what I'm going to do is I'm going to detach the camera on the y-axis. So right now, I'm using the origin, which is a vector 3. So I'm going to duplicate the line, and I'm going to just affect x and z. So z, no, x and z, and x and z. It should work. It should basically do the same thing. Okay, it does it. It's doing the same thing, but this time it's not following in the y direction. So that's something that for now will work. In the future, if for example we have a path going upward or a platform going upward or something, we need to make sure that the camera will follow at some point, because it's cool that it's not following when you're jumping, but maybe if we go really higher, we need to follow. So you can use like some sort of ceiling to make sure that you're following the character correctly. But for now it's fine, because what I'm doing is mostly flat. It's mostly flat, so it's fine. I love GDScript and Godot. Sadly, 3D is a bit lackluster for now, so it's not my first choice for 3D games. For 2D, on the other hand, I much prefer it over Unity. I totally agree with you on the 2D aspect. Like, Godot is clearly made for 2D. Like, I know that it started as a 3D engine at first, but on the 2D aspect, it's like, I think the best. Right now, for me, it's the best, and especially with the new features that will be coming in 4.0 and stuff, the new tile map editor and all of that, for 2D it's just the best. Especially since Unity, when you're doing 2D, you're basically just faking 2D by doing 3D but looking at it like a plane. So yeah, it's much better for 2D. And for 3D, I don't know. I think it's good, but it's lacking some things, of course. And I hope that with Godot 4, it will be enough for people to start really working with Godot in 3D. Personally, I'm doing things in Godot in 3D and even in VR. I'm doing a client project in VR, and some things are missing, some things are a bit rough, but I'm managing to do something, so I guess it's fine. I guess it's possible to use it. If you really want to, I guess it's possible, but you have to be aware that some things you'll have to do them yourself, for sure. That's the only pain point, I guess. Okay, so right now what I want to do, I want to create the platform. I want to create the platform that you will push as a player. And the platform, I'm going to basically make the same stuff I did in my video on physics-based hoverboard. I think it was the name. You can check it out if you want. It's a pretty cool thing, I guess. I think you'll see. You'll tell me what you think. It's physics-based, so it's cool. It's always cool. Another advice, if I can give you advice, is in a game jam, it is not a good idea to rely heavily on rigid bodies unless you know what you're doing. And in this case, I'm basically doing that, which is a bad idea, I think. I think it's a bad idea because you have less control over what's happening. You're gaining a lot of time by not making the interactions yourself, but you're losing time because it can get messy, and you won't understand why, maybe. So we'll see. We'll see how it goes, but right now I'm doing it that way. Okay, so let's add a spatial material to our little platform right there. Let's make it, I don't know, some color just to see it. Okay. I want to create a collision shape for that. Same, I'm really hoping that Godot deserves some love. Yeah, and Godot is getting some love, especially with this event. And thanks a lot, Really Fine Game Dev, for making this event. I think it's a good way to get people on board, to get people to know Godot better, and in the end, I think it will be profitable for everyone. It's promoting Godot, it's promoting the community, making tutorials and events around it, so it's cool. John Russell, I learned that the hard way. Don't worry, I did that too, and I didn't learn my lesson because I'm doing that again. So I guess it's fine. Remote transform. I'm going to create 4 remote transform, and you'll see in just a second why. So I'm placing them at each corner of the board. If you don't know remote transforms in Godot, it's an amazing node. Basically, this node will copy its transform to a remote node, and you can choose what it's going to copy. So, first of all, let's remove the rotation and the scale. Okay? Let's remove that. And you'll see in just a second why we need to use that. The second thing I want to do is I want to create some Raycasts. So as you can see, the Raycasts are not children of the rigid body. I did it that way, but you could just put them as children and then set them as top level. That way they are not affected by the transform. But I'm doing it that way. That way it's simpler. So I'm doing the same thing. I'm positioning them roughly at the good spot. It's just for me to visualize because they will be updated by the remote transform, so it's not really a problem. Okay, so we can see them here. Let's enable them. Okay, in Godot it's really important. Raycasts by default are not enabled, and this is a pain. You will forget that, and it will cause you trouble. And I want to cast to minus 2. Let's say minus 2. We'll see later. We are going to put them on the second collision mask because I don't want them to collide with this, or we can just put them more towards the bottom. It's the same thing, you do as you wish. So I'm going to add the second layer to the floor because I want to collide with the floor. And okay, so right now what I want to do is I want to assign the different remote transform to the corresponding Raycasts. Okay. Oops, sorry. And now if I take the rigid body and I move the rigid body, the Raycasts will follow. So that's pretty cool. They will follow, but look at it. They won't rotate. That's what I wanted, okay? I just wanted the Raycasts to be always pointing towards the ground. And with this setup, we have that basically. So that's cool. Yeah, I can't seem to get my player kinematic and rigid body to interact, and I don't know what I did. Oh, stay tuned. Draftin Gish. Yeah, sorry if I don't pronounce it correctly. Stay tuned because we are doing just that. We are going to set up the player kinematic body with rigid bodies interaction. So stay tuned. We are going to do that in just a second. Okay, I need to do something else. This is a lot of setup. I'm sorry, this is a lot of setup, but it's interesting, I think. I'm going to add the rigid body into a group, and the group is going to be platform. That way I can check it. And I'm going to add the Raycasts to another group also. And the group is going to be called Raycasts. That way I can easily interact with them. Okay, so let's put that into scripts. Let's call that platform body. And I'm going to rename it platform body. Okay. I think our setup is okay now, so we can just start to code. We can just start to code. Okay, so we are going to do... basically, what we are going to do is pretty simple. We are going to go... Let me explain to you real quick. We are going to loop through all the raycasts. We are going to get the collision points of those raycasts. We are going to compute the distance. And then we are going to apply a force based on this distance, okay? We are going to apply a force to the platform. And with that, the platform will stay level. You will see, it's pretty cool. So, the first thing we want to do on ready var, we want to get all the raycasts. So I'm going to go raise, and I'm going to call get tree, get nodes, in group, and I'm going to call the group raycasts that I just created. So with that, I have all the rays inside this. And now, inside the physics process, I can go and loop through all the rays. So let's just do that right now. So for ray in rays, I think I can do that. The first thing that we want to do is we want to force the raycast update. If we don't do that, we are going to get the result of the raycast from the previous frame. It's not really a problem, to be honest. I think you can. I think it will work fine with that. But depending on what you want to do, you can just force it to have the result right now. Okay? I think it's fine. Let's do that. We don't care about performance. It should be fine. So we're going to check if our raycast is colliding or not. So if colliding, if we are not colliding, what I want to do is I want to return. I want to continue, sorry. I want to go to the next ray, because I don't care about this ray. I'm starting to do that more often in Godot, in programming in general. It's called early return. Instead of doing... So usually, when you learn programming, you learn to do that. And now, you want to do whatever you want. You learn to check if something, and then you do something, else you do something else. But I find it a bit cumbersome. So what I'm doing is, first of all, I'm checking if we're colliding or not. Because if we are not colliding, I don't care about the rest. So I can just continue, and continue will go to the next iteration in the for loop. So I can do that. So now I know that I'm colliding. So what I can do is get the collision point. So I can go ray.get collision point, I think it is. It's a shame that here I can't do that. I would love to do that. You know, I would love to cast the ray as a raycast, and I don't think I can do. Like, can I do it that way? No. In a for loop, I don't think I can say what type it is. But yeah, it's not really, it's not the end of the world. So then we can compute the distance. So the distance is the distance between the collision point. We can get distance 2, and basically it's the distance through to our raycast, just like that. So with that, we have the distance between the raycast, which is about here, and the collision point, which will be somewhere along the line. we have the distance. I know that with Godot physics, we need to make sure that we don't do... I mean, not with Godot physics, that's not what I wanted to say. We need to make sure that distance is not 0. It shouldn't be, but if they are like touching, it may be. So, if is equal approx distance and 0, we'll go continue. I'm using equal approx because we're using floats, and floats will never be exactly 0. They will be like 0.1 or 3 or epsilon value something. So you need to make sure that you're using that is equal approx. So if the distance is 0, we continue because we have nothing to do, and if not, we can add force. So we are going to do that in just a second. Can't you define a local variable ray as raycast before the loop? Maybe. You mean like I can do that? And then variable ray already defined at scope. Yeah, but then I need to... Yeah, I see what you mean. Like you want me to define the raycast and then maybe use I, and each loop do get raise.get, and I see. But yeah, what I would love to is to have the same syntax as this, which is very useful and very easy to type, but just being able to add some type like this. Like I want to type my variable, that would be nice. But I don't know, maybe it's under the hood it's too complicated. So what I want to do now is I want to add a force, but I don't want to add a force anywhere on the rigid body. I want to add a force exactly where the raycast is. I want to add a force going up, like this, like going up, up, up. So we can do that with add force. So our vector is going to be a vector 3. We want to apply a force going upward, so we can use vector 3.up. And we're going to multiply this by the distance, but we want that to be inversely proportionate to the distance, because as we get further away from the ground, we want the force to be smaller. But as we get closer to the ground, we want the force to be stronger, to push us away from the floor. So we can go 1 divided by distance. And we also want to use a force, because this will be much smaller than what we want. And for that, we are going to go over force. I need to define it real quick. So let's define a variable called hover force. And the force really depends on the mass of the body and stuff, so we'll have to check that out. True, it would be cool to be able to do that. Sometimes when I want to autocomplete, I do something like ray as raycast property. Otherwise, it doesn't matter to me. Yeah, I understand. That's exactly what I want. I want the autocomplete. Otherwise, I don't really care in this case. And also, it's just easier to program when you have autocomplete, because from time to time the exact name of the function I will not remember. Like, is it force raycast update or raycast force update? Like, I don't know. It really depends on how your brain is wired. So hover force, we have that. Okay, that's cool. Then what we need to do is we need to get the position. So this is interesting. In Godot, basically you can say that in Godot, when you are working with physics, everything is in global coordinates, okay? Everything is in global coordinates. That's the way the physics server is handling stuff. So we want that to be in global coordinates, but the position is relative to the body itself. So we can do something like ray.global global transform.origin minus global transform.origin, which is our, let me put that way you can see. So this is the global transform of the ray, and this is the global transform of the body itself. And with that, we basically have the distance, the vector between this point and this point, but in global coordinates. This is important. At first, I had a lot of trouble with that when I made my first video on the subject, because it was a bit confusing. I think that's all we need. Now we just need to set up the body to have we can use the contact monitor. Maybe we're going to use that continuous CD. Okay, something very important is we want to add some damping. This is important because otherwise it will go out of control very fast. And the more damping that we want is in angular. We want angular damping because our body is going to roll like this. So maybe something like 4. We can check later. Maybe something, if you want it to be really stable, we can go like 6 or more. And linear damping, I don't want too much linear damping because I want that when you push the body, it will slide a bit. And if I put too much damping, it will not slide. So that's cool. We can maybe change the mass a little bit to make it a bit heavier. Is that it? I think it is. So let's go into the test and let's instantiate our platform. We can put it somewhere like there. So the platform will fall. Oh, when it bounces really fast. Wow. It went a bit out of control. That's funny. Let's check if we put the thing. Yes, that was a lot. Oh, I know. I think I forgot to add delta. So it's going to matter a lot. Like I'm adding the force every frame, but I'm not using delta, so the force is like super high, and now it works better. As you can see, it's still hovering, like it's not very stable. It's not very stable. Let's check. It's not super stable, but let me just check using this view. Let me just check using this view that we are hovering, so it's fine. Yes, it is. Okay, so it works, and right now you can see that we have interaction with those two. Okay, so that's cool, but also it's not really what we want. Maybe my platform is a bit small also. We don't want that because right now the inertia is infinite, which means that if I go on top, it will like act as if I have infinite energy, so it will like go through the floor and stuff. So it's not a good idea. So what we want to do first, we want to go to the player. We want to go there, move and slide, and we want to put that to false. And with that, we don't have any interaction. But look at this, because I was having a lot of trouble the first time I did that in Godot. So I'm using Godot by default right now. I put infinite inertia to false, and it's still pushing the thing. So it's weird, right? Okay. And you know why? It's because by default Godot is using physics. It's using bullets. Let me check. 3D physics. No, not in layers. Just in physics. 3D. By default, it's using bullets. currently bullets, and bullets will not work correctly. So let's go to Godot Physics. Yeah, IntelliSense is really cool. I would love to have it. Hi, Mr. Elliptic. I'm lurking for a while. Nice stream. What? Hi, Hybrid Lizard, and thanks for joining. It's cool to see you. Same for Gilan S. Hello, Octagon. Welcome. Welcome. All right. So right now we don't have, I changed the Godot Physics, so right now it should work, like, okay, right now I can't push it anymore, I can go on top, it doesn't, basically there's no interaction with it. So that is good. Let me do something real quick, let me make the platform, let me make it a bit bigger, because clearly right now it is way too small. So maybe something like 6 by 6. So let me change the collision shape, 3 by 3. And so I need to change the remote transform also. I need to put them in the corners. So this is important. If you're doing something like very serious, put them at the right location. Like put them at the exact location on each corner, with the same offset, I mean. If you're not doing that, you will have some trouble, because one is going to push more than the other. In my case, I think it's big enough so that it won't really matter, but still. Okay, we have that, we have our player. What we can do is we can set up the physics interaction between the player and the platform. Yeah, we can do that. So we are going to define a push force. I don't really know, something really small, I think. So var push force. We'll start with something, push force. We'll start with something very small, 0.5. So I'm not working on the octagon, I'm sorry. But I can make something that is an octagon, it's possible. Okay, where am I? I have the push force. So now what I can do, in the physics process, I can get the collisions. So let's do that. Can you see clearly the code? Yeah, I think you can. So guys, remember, we are doing that for, I am doing that for the GoGodot Jam 2. If you want to join, you can still join. You have 5 days left for the GoGodot Jam. Let me push the link in the description. You have all the links in the description of this stream. You can check the events. There are a lot of events. There was an event just before mine video, which is pretty cool. You still have a lot of events if you don't want to participate in the jam, but I highly recommend participating in a jam. It's cool. And the theme is energy source. Okay, so let's do something. Let's do get slide count. So again, this is a function that we find in the kinematic body, and it's the collision that you will get after sliding. So we have move and slide, and we can get the collision that way. So if we have no collision, we can simply return because we don't care. But if we have, what we can do is we can get var collision. We can do something. We can do for I in range get slide count, and then we can go var collision equals to get slide collision and use the index. That way we will loop through all the collisions. It's important to do that because you are sliding across a surface, you will probably have multiple collisions. So if you only consider the first collision, maybe you're missing some of them. So that's important. And basically what I'm going to do is I'm going to go if collision.collider.is in group platform, I think is the group that we used. If it's not in the group platform, we can continue. There should be a better IntelliSense autocomplete with Godot 4 and later. The problem currently is that the optional static typing is limited in JavaScript. I think they will expand on it, allowing for a better autocomplete eventually, as long as a person will provide types. That makes sense. Yeah, get myself for the VS Code, even for JavaScript, just to use my second monitor. That's why I have an ultra wide monitor. So right now I'm using my left monitor. You can see me, like, I'm not looking at the camera because I'm using my left monitor, which is a 16:9. But usually I'm using my ultra wide monitor. That way I can have the whole Godot window taking all the space. But I agree that having the code on another screen would be much better, especially when you need to run. That it would just be much better for a lot of people. So I agree that that would be cool. And also, yes, if you use static typing, you get much better autocompletion. That's why I was not really happy with the for loop here, because I can't type this variable, and thus I'm not getting the autocompletion for those methods, which is a bit painful. But it's fine, I guess. Okay, let's start. The good thing also is that with Godot you have everything inside the editor. It's a good point in my opinion, for especially for beginners and maybe for some people. Like in Unity, the fact that you have to use another editor is painful to me. It's good to have the possibility, but I like to have it directly inside it also. From what I've seen, multi-window support is in progress, let's say, with some important enablers ready or in progress. There is just a focus on other stuff at the moment. Yes, I guess it's not the most needed feature, and I guess it's a hard feature to implement. Like to implement well, to be sure that it will work correctly, that you can dock back the windows, that there's no memory leak, that it won't crash and stuff. I guess it's a hard feature to implement. Much harder than some people may think it is. So let's get back to my code real quick. So basically we are checking if the collider is in group platform, and if is not, we continue because we don't care. So what we can do now is we can go collision.collider. We know that it's the platform. So we can apply a central impulse. I guess that's what we are going to do. And for that, we are going to use the collision normal. I know that we are going to have a problem. I use platform, right? In the group platform, yes. I know that we are going to have a problem right there. Because we are going to get the collision normal. But we can still do it. We can still do it and see what happens. You want me to make something that will not work? We can do that. So collision.normal times, I think we have something that is called push force. So I can tell you why it won't work. I want my platform to be pushed horizontally, basically. But the collision normal is a vector 3. So it will have a y component. So it will push the platform with the y component also. But we can check that. So let's check that. Let's check if it's possible or not. Okay, so clearly we can see I got pushed into the ground, I guess. Huh, that's a shame. But clearly we can see that it works, but it will push the... Yeah. It will push the platform also a bit up, and if you go on top of it, it will push it down. And I don't want that. I don't want that because it's just much harder to implement. Like, I want to be sure that the player will not get stuck. So what we can do is we can create var normal 2D. We can create a vector 2. So let's do that. Let's do a vector 2, and we are going to use only the collision normal dot x and x and the collision normal dot z. That way we don't I need a vector 3 I'm sorry, I need a vector 3. So normal horizontal, let's call it normal horizontal, but I will just put the y component to 0, and then I can use that, and now it should work. I mean, it worked, but it should work better. Okay, the only problem is the platform is a bit high, so maybe we can allow the platform to go a bit lower with less force. Good, I'm hopeful for the time being. I will suck it up using VS Code. My vertical screen just for coding is too good to use. Yeah, I see. I'm using my vertical screen to have Spotify and Discord open. I'm not using it for coding. I'm pretty sure there was a checkbox somewhere to limit physics movement to 1 or 2 planes. Yes, there is. Yes, there is. But I don't want that. I don't want that. Because I want my platform to move up and down and left and right and to do whatever. Because I want it to react to the terrain. That's why I'm using Raycasts. That way it can go uphill and it can go on into bumps and stuff. So I still want to use that. So I don't want to force the interaction that way. So okay, so now we have that. Let me check real quick. Let me put that in bigger screen. We have that. We have our controller. We can go on top. We can go to the left, push the platform. Push the platform. We can go on top of the platform and go with the platform. Let me do that quicker. And we can go with the platform, so that's cool. It is going to fall. Okay, let's move out of the way. For floating, yes, exactly. I want it to be able. I want it to float. Just to see better, I'm going to use an environment. And let me change the music real quick. It's a bit slow. Okay. I'm going to use a world environment, and I'm going to use a directional light real quick. So the directional light, you can put it everywhere, wherever you want. I mean, the height doesn't matter. And then I'm going to rotate it a bit. Okay. Inside there, I want the shadows to be enabled, and I probably want the shadows to be not so strong. Okay, and inside here I will create a new environment. I will put the tone map to Assess. Ambient light, I want the sky contribution to be much lower, and I'm going to create a sky again. I don't want to spend too much time on the sky right now. I don't really care. So we have a sky, and now we have some shadows. That way we have another indication of where we are in space. I think that's important for the player. You know that you're jumping, you know how high and stuff, so that's cool. Okay, I might have a USB problem because I heard a disconnect or something. I don't know if you're aware of this, but I thought I'd share this anyway. If you use F8 instead of clicking the X button to stop a running instance as a side effect, though, exit tree is not called. I'm not sure I understand. You use F8 instead of clicking the X button to stop a running instance. As a side effect though, exit tree is not called. You mean when if I use F8, it will not be called? But I guess it's the same as using the button here, right? So I know that this button will send a signal, it will send a notification that you can intercept. It's a close notification and you can do stuff like stop the controller vibration or whatever. And what you're saying is if you're using F8, you don't go through that, it just kills the process, I guess. But I guess it's the same as this button, which is, oh yeah, F8, it's the same, okay. That's good to know, thanks. And also it's good to know that F8 is already used, because I wanted to use it for I wanted to make an add-on to run custom scenes, and I wanted to use F7, F8, F9 to run different scenes, but I guess it's not a good idea if it's already used. So we'll see. Okay, so we have that. Now what I want is I want to create a body, a rigid body that I can grab, and that's going to be cool. So that's not what I want to do. Let's call it grabbable. It's grabbable because you can grab it. Oops, I messed with the name. Grabbable. We're going to attach a script and put it there. I want no comments. Okay. So let's make it a tad bigger. Do I want a new physics material? I want a lot of friction, I guess. If true, the physics will use friction of their. Okay, it's rough. And it's not bouncy. I use it as a keyboard shortcut for convenience while learning my game. But node.exit tree is not called when using F8. Yeah, okay. I guess it's because you're just killing the process and you're not asking the process to terminate. You're like closing it by force. So that's a bit of a problem in some cases. If you're dealing with files, with different stuff like this, maybe you need to make sure that you're releasing them correctly. Okay, let's go. Let's add a mesh and let's add a collision. So for the mesh, I'm going to use a simple cube right now, but it's a bit big, right? Okay. I'm going to change the color just to be able to see it clearly. But of course, later on we need to make something a bit better than this, because clearly this is ugly. We need to create a box shape. So you see me create shapes manually, and you probably know that you can create them using this. But the thing is, I want the simplest shapes possible for a performance reason. So that's why I'm creating them manually. We want 0.75. And that's our box. Amazing. We are going to add it to a group, which is called grabbable. I don't know if it's an English word or not. Something that can be grabbed. I don't know. But grabbables, because there are multiple inside there. But I think it's fine. We can do something also. Maybe we want to be able to push them. So we want to check two things. We want to check that, or no, and so if it's not inside the grabbable group or the platform group, we want to return. And we can already put some grabbable items somewhere around there. Alright. I think it's 1B. Oh yeah, maybe it's 1B. Too late. I used 2. And I can't push them. But I can push that. Oh, maybe I can't push them because it's too heavy. I don't know. It's not a problem for now. Oh, maybe because player. No, that's it. If it's not inside this group, I'll grab a balls. And now I can push them. Wow, amazing. That's cool. That is cool. Okay, so now what I want to do is I want the player to be able to grab them. So I'm gonna use a position node that I will put somewhere around here, maybe. I don't know. It's going to be the grab position. I'm just gonna rename real quick those things to know what they are. This is the eyes, this is the body, and those are the feet. And we already have a body, so body mesh and body. Okay, fine. I also see that I need to rotate a bit faster because it's lagging behind, but it's fine. If you guys are interested, I will probably continue this game tomorrow. Tomorrow I will be streaming on Twitch. I stream on Tuesday and Friday, at least for now. Maybe more often in the future. But if you want, I will probably work on that if I feel motivated enough. And we'll see. And maybe I will make another event in the future to continue this. With maybe some more interesting things like level design and stuff, because I don't think we'll have time tonight for that. But at least we will have all the interactions and stuff in place. Okay. I think that's it. We need an area. And with the area, we are going to add a collision shape. I'm going to place the area somewhere around there. That way I have the same transform, and I want, let's say, a box shape. Yeah, that's cool. And with that box shape, it's everything that will be inside this shape I will be able to grab. Maybe I can make it a bit closer, that way I can grab it if it's like really close. That should be fine, that should be fine. So we are going to monitor two things. We are going to monitor body entered and body exited. Alright. Let's do that. So first of all, if the body is not in the group grabbables, we don't want that, okay? And same thing for that, we don't care. Also, can the area collide with myself? Like, maybe it will collide with myself right there. Oh no, I don't think so. Okay, it should be fine. It should be fine. And basically what we will do is we will create a variable called in grab area. At first it's going to be null, and when something enters and it's grabbable, that meaning that you can grab it, I want to paste it. I paste nothing. What? In grab area, I want to put the body inside, and if in grab area is equal to the body, we want to make that null. So if you want to recreate that, I also did a video on that. It's called recreating control object throwing or something. I don't remember the name exactly of the video, but you can do that if you want. And basically it will teach you how to grab rigid bodies and throw them. So that's exactly what we're going to do right now. Okay. I think that what we want to do is we want to make sure that we can grab them, so we want to add a new action which will be called grab. I usually work on collision layers rather than hard code what can interact with what, but I guess this works too. Yeah, you're right, I could do that. The thing is, it's probably better, but also it can get messy. Collision layers can get messy because it's not obvious from the code, from a code point of view, it's not obvious if you can interact with something or not. So if you have a lot of things going on, it can be a bit hard to know, but I don't know. It depends, I guess, on your workflow and on what you're used to. So I'm gonna use the key E, and I'm also going to use the joy button R2, let's say, and also the joy button B to grab. Okay, and now what we can do inside the process function, we can check if input dot is action pressed grab. We can check if area, I don't remember the name, yes, it's there. We can return if it's null. If it's null, we can return. And otherwise, we can call grab, and we can give it the grab position, because it's going to use the grab position. But also we need also to check if the body is grabbed or not. So we'll have to do that also. So I guess we can do that right now. We can do if grab position dot get child count. Probably not the best way to do that, but you can do it in many ways. So if the child count is superior to 0, it means that we have something. So let's check if we have nothing first. We have if we have nothing, we check if we have something in the grab area, and if we don't, we return. That's okay. But if we have something and there's something in the grab area, we can grab it, basically. Okay? So this will work. Else, what's in the grab area will be dropped. So let's call it drop. Drop. Let's call it drop. Not in grab area. Oops. This won't work. Grab, it will work actually. Grab point grab. We have the body. Yeah, okay, it should work. I have a global singleton that has enum which puts a name to each of the collision layers. Then I can call get collision layer bit using that enum. That's cool. Yeah, that's a cool idea also. I think it has the advantage of using the layers, which are pretty cool, but also having the ability to check with code and with ease, with something that is like, thanks to the enum, it's like understandable for the programmer. So that's cool. Hey VTK, welcome to the stream. So we have grab and drop. So I guess we can create those inside the grabbable. So function grab. So as you can see, what I'm doing with the new parent, I think we can call it. What I'm doing with this jam is maybe not a good idea for like, for me it's fine because I don't really want to enter the jam. But be careful with using complicated mechanics, because I mean, it's not super complicated, but we have different things interacting and with physics and stuff, so it can be messy and it's prone to bug. Clearly what I'm doing here, it's prone to bug. So you want to think about it before doing that for a game jam. Do you really want to make something a bit complex? Maybe not. Maybe stay with something simple that you know will work, and then you can work on that. Okay, so let's do something first. What I want is to remember my original parent, because I'm going to reparent the rigid body. So first of all, I'm going to create a original parent, and basically I'm going to call the get parent. That's the first thing. I also want to remember my previous transform, because I'm going to need that when the new parent will drop me. You'll see in just a second. So basically, the first thing is reparenting. Reparenting. Okay. The first thing is reparenting. So what we want to do is we want to call original parent, remove child, and we want to remove ourselves from the chat. Then we want to call new parent, and we want to add a child, and we want to add ourselves again. Then we want to change our mode. So let's change to mode. I can't type. Mode static. Okay, we are now going to be static, and we can reset our transform. So I did a video on that if you want to check, and Bastian also did a video on that in VR, so you can check that if you want. Reset transform. It's important to reset the transform, because otherwise we will keep our previous transform, and thus we will be far away from the grabbing point. So by resetting the transform, we basically take the transform of the parent, and in our case, the parent is this point. It's the grab position. So that's pretty handy. So we do that. So we reparent, we change our mode, and we do transform. We reset the transform. We can also maybe have a variable that we'll call grab. Grabbed, maybe. I'm using 2b again, but I don't know. And we can set it to false at the beginning. And now we are grabbed. Okay. We can also do drop. So for drop, we are going to go we are going to do the same thing basically, but in the other way around. So we are going to get our parent, remove the child, which is self, which is ourself, and then call original parent and add ourself. Okay? I think it's fine. We can global transform. We can create. We can. We need to remember. Oh yeah, okay. We need to use this transform. So what are we going to do? We are going to go var transform. We can take our transform right before changing parents, okay? We change parents and then we reuse the transform. That should work. We need to also change the mode, and now we need to be rigid again. And we can apply a small impulse. That way we'll be able to move away from the body. It's going to be a small impulse. We can use that. We can use the parent. So the parent, we can use -z to go forward, -z. So let's do because we have the transform of the parent, we can go minus global transform dot basis dot z. So we are going in the -z direction, and maybe something pretty small, like really small, 0.5. I want something like pretty small. And is that it? Yes, it is. To make sure I'm leaving the area, I won't set the grabbed to false when I'm dropped. I will make sure to leave the area first. That way the body will not grab me again. I think it will be better that way. So we can do that. We can go here. Body exited. We can go there, and we can just before that we can go in grab area dot grabbed equal to false. Okay. If the body that we had inside the area is the same body, then we can return. Also, that's it, I think. Yes. If we have something in if in grab area, so if it's not null, we can return. Okay, because we don't want to grab something again. Let's see where we are right now, and maybe we'll have to do something else. So I'm really close. I'm pressing B, and now I'm grabbing the thing. Okay, so that works. So I can go around with the cube. The only thing is I turn the body into a static body, so it's still a physics body, so it will still interact with everything else. So we need to make sure that it's fine for us. And you see, because I'm moving a rigid body, it will like go through the others. So maybe I can change collision layers or disable it. Maybe it's better to disable it. So can I launch it right now? Okay, I can. And then I can push it, and then I can grab it again. I can push it, put it there. Put it there. Okay. And we can still push that. Okay, so that's fine. So we have our mechanic. kind of working. So as you can see, when I'm pushing the thing, what's interesting is that it's physics based. So if I put this one like right, oh, it's really sensitive. If I put it there, you can clearly see that it's tipping on the right. But I think that's cool because you have to like be aware of that and put another one here to make it more stable. Then if you go too fast, it will probably do weird stuff. Okay, I think the interaction and stuff can be interesting, and of course you can go on top of it and you weigh nothing basically. So I think that's a good thing, and you can go on top of those things if you want. So maybe I want to do like, oops, maybe I want to put it on top. Don't know if I will be able to. Okay, it's a bit hard because it's a bit hard because the physics is not disabled. So let me change the mode, but let me also disable, I think, the disable or change layers. I don't know what is the best. I guess it's similar, right? I think it's similar. I don't know which one is best. So what we can do is we can go collision shape disabled equal to true, and there we can go false. Usually you don't want to change the collision shapes like this. You want to use call deferred. In grab area drop. Oh, because it's not. That's a problem because it's not exiting the body anymore. It's not exiting the body anymore because it's not on the same. It's not detected because it's disabled. So maybe we can just change the layer. Wouldn't that load drop one inside another? Allow to drop one inside a load. Oh, to do what I'm doing right now. Yes, it would. Yes, it would. We have different solutions if we want. We have different solutions. Like at first, what we can do is we can do it this way, and the thing is, you're right. We can put it inside another box and drop it there. Fortunately, the physics server will probably separate them and push them apart, and it will work. So that's one solution. That's the easiest one. But there's something else that we can do. We can turn maybe we can turn the grabbable body into a kinematic body instead of a static one. I don't know. Maybe we can do that, and we can then set up the collisions however we want. Or last solution, we can keep it a rigid body, but attach it with a joint. We could do that. We could attach it to a joint. And maybe that's even simpler. I'm not sure, but maybe that's even simpler. I need to think about that. Because if we use a joint, like I could have a joint here, let's say a pin joint. So I could have a joint on the body somewhere like there. And instead of reparenting everything, we could just set the nodes. So the first node will be our player, and the second node would be the other thing. Maybe that's a solution. I need to try that. So right now, I'm not going to care too much about that. We'll see. Try the joint. Seems the easier path. Yeah, I'm trying to think about it. Like, is it really the easier path? Like, maybe there will be something that I'm not thinking about. I don't know. Well, I think it's a bit. I think it's a bit heavy. Oh, and if you go too fast, it will fall. That's interesting. So that's the cool thing with physics. Based games, is that it will create some interactions that you didn't think about. And so it adds a bit of fun to the game, I think. And if you put this one also, it's probably going to be too heavy. Please stay. Please freaking stay. Stay. I can push it. Ah. Shit. It's not what I wanted to do. Ah. Come back. Here. Oh yeah, it's really heavy now. It's touching the floor, basically. I hadn't thought of using joints. Was running into similar issue. Yeah, joints. It can be a good solution. Walmart employee simulator. Basically yes. Increase the friction of the grabbable ones on the platform. I think the friction is already at max. Like, look at it. Grabbable. We have the grabbable here. I have a physics material. Friction is at 1. So it's the maximum friction. And it's rough. And rough means that the physics engine will use the friction of the object marked as rough when two objects collide. So it's already max friction. If you don't want to slide, yes, I don't know. Maybe it's fun that they can slide. I was thinking that maybe we can have like some small barriers, some rails that would allow to stay inside. What do you think? Maybe we can have some small rails, and that will probably help. Oh, I'm starting to be good. Oh, look at this. I will... Oh, but it will push them. So that's not a good idea. I can't do what I want. I want to jump there and put it there. Oh, it works actually. Oh, cool. That's cool. But now it's clearly too heavy. If you don't want them to slide. Yeah. So I don't know. I'm not sure. I can push them also, maybe. And I can, like, mess with everything. Oh. Okay. We need to make sure that this can't happen. But it's okay. I can try the joint version. Rail sounds good. Yeah, maybe it will be easier. Let's add some rails. So let's do collision. Let's do mesh. I'm going to make the mesh first, and then we are going to create the thing. Should I go with like meshes? With rails, like real rails? I'm not sure. Let me check. I don't know if in Godot physics you have cylinder shapes. Yes, I guess you have them. Okay, so let's make them pretty small. 0.2, pretty 0.1, 0.1. That should be fine. We want the segments to be much smaller because we don't need that much geometry. And I really like how it plays, but I'd rather have them not clip through each other. It makes it feel cheap. Yeah, you're right. That's why I will try the joint version. But guys, I don't think I will have the time to do it today. So I'll just finish that real quick, and because I need to go then. It's 8 here, and I need to go to the gym to make flips. I'm going to it's like the gymnasium, and this is where I train my flips, and it's starting soon. I don't have a lot of occasions to do that, so I don't want to miss it. But if you're interested, I will probably do that again tomorrow. So you can join tomorrow on Twitch this time, and I will probably do another stream on YouTube for the jam, for the GoGodot event. Let me just do a shameless plug to my Twitch channel. And yeah, so we have the rail now. We have the rail. Let's rotate the rail. Let's rotate it in Z. So 90 in Z. It's still too small because this is 6 meters. So let's put that to 6, and let's put the collision shapes to 6 also. Okay. Oops. I want to move the mesh instance probably around here. And because it's a rail, it's a floating rail, let's say. I also need to be able to jump on the platform, so it shouldn't be too high. So something like this should be fine. And then we can create 2 more that we will rotate in Z. Rotate in Z. And guys, don't forget to join the jam if you didn't already. You can check also all the events on the website. Every links are in the description. But I guess you probably already joined. If you're here, it's probably because you know about the GoGodot Jam. Probably. But still, it was really cool being with you. Thanks for it's not finished like right now, okay? But I want to thank you for being here, being with me. It was a cool moment. I hope that your games are doing well. If you're like working on something, I hope that you're not having too much trouble. We have the rails now. Whoa, look at it. Amazing. Why is the collision shape? I don't know why. I have a feeling that in Godot, with Godot physics, you don't have cylinder shapes. But we do, I think. Wow. It goes through. It's like there's no shape. What? It's like there's no shape. What the fuck? What the fuck? I hope you'll be able to play my game too. I'm here just out of curiosity, actually. Oh, okay. That's cool. Well, good to know. I hope it was interesting then. And I hope you'll be able to play my game too. Yes, I will probably, after the jam, I will probably try to stream either here or on Twitch. I usually stream on Twitch. I will probably try to stream some entries. And yeah, I think that's a good thing. Try to create the trimish static body. Oh yeah, maybe you're right. But I have no message. I have no error message. But I feel like I remember that the cylinder shape doesn't exist in Godot physics, which is a bit weird, but it doesn't exist. So trimesh collision sibling, we're going to do that. Let's try that. Let's try the trimesh collision sibling. Oops. It's probably going to be more expensive in terms of calculations, but yeah. I can also make a simpler version. We'll see. It's still going through. That's weird. But it... Oh! I'm dumb. I'm dumb. I'm dumb. I am dumb. I am dumb. And I can't control Z? Ah, I can. So let me control Z. Until I have all of that. Okay. You know it needs to be a physics body node to be interactable, I guess. Yes, exactly. But I already have a physics body, so I just need to inverse. Inverse. The mesh has to be a child of the... I mean, the collision shape has to be a direct child of the physics body. I completely forgot. And now it works. Yeah, we can see that there's a... Clearly there's a collision. Okay, now it works. Alright. That's cool. So yeah, it was just that. It was just that the physics body, the rigid body, will take into account only the direct child that are collision shapes. And because those two were swapped, it was not recognizing it. So yeah, it will now work better. So in our test scene we have that, and I think in the future actually what I want to do is use CSG nodes. That way I can create a terrain. I can like roughly create a terrain pretty fast using like this and not this, but this. Like I can create a terrain like this. Like this, maybe. And even though CSGs are not the best for performance, they allow me to create something pretty fast. And I think it's better. So we can use the same material, paste. And the good thing that we need to do is CSG box. We need to call use collision right there. Collision layers 1 and 2, and now it should work. And then we can create basically create a world where you have to push your thing. And whoa, that was weird. I'm stuck. Why am I stuck? Why am I stuck? That's weird. Okay, let me push that. That was weird. You saw that? You saw the glitch? I don't know. So we can have something like this. And we can have like swinging things that will try to push your cart. You can have holes, you can have things. Okay, that's weird. There's a weird... From time to time, the interactions... Wow. Oh, I think I know what it is. Because I'm using cylinder shapes on the side, and I'm pushing the cart based on the collision normal. Like, probably the collision normal is doing something weird because it's something cylindrical. Cylindrical? Is that a word? Well, it's a cylinder. And probably that it's not amazing, so maybe I can just use a rectangle, and I think the collisions will be much better. Because yeah, we can see some glitching because of that, I think. I'm not sure though, but I think, because I don't know why there would be such glitching otherwise. We didn't have the glitching before. But yeah, now we can like use that and create we can use that and create different paths and stuff. I think CSGs are good for that. It's very easy to prototype something, and then maybe we can just send it to Blender. I think now we can export. I don't remember where, but I know that we can export somewhere. Or maybe it's an add-on. I don't remember, but I know that you can export. Yeah, so too bad. We need to change that to make something a bit more interesting. Maybe I can do that real quick. That way I can... yeah, let me do that. New box shape. Top radius 0.1, 0.1. So I guess 0.1 should be fine. Yes. In up direction it's in Z. Oh no, in Z it's 6. Too much. 3, because it's extents. And 0.1. Project tools. Export GLTF. Okay, thanks. To export GLTF. Thanks, Zero Wolf. Thanks for the tips. So clearly that's a good thing. We can like make the levels with CSG, then export that to Blender to have the same scale and everything, and then we can create a better world if we want to. So that's a good thing. So what I will do is I will take this shape and I will use it everywhere. And we're going to try real quick to see if it's different or not. And I think now it won't bug as much. Well, I need to put the thing inside, of course. Let's put it that way. Okay, clearly now it's working better. So I think it was the shape. And you saw when we are going to fall. We are going to fall. No, okay, cool. Okay. Okay, I think we have something. I think it's fun enough. Maybe we can do some work on the camera to make it a bit smoother. And maybe further away, because we can't really... Maybe a bit higher. Oh. That was fast. And now... Oops. Oops. But you see, because the cart is physics-based, we have some cool interactions. Like, when we go down here, you can see it goes down smoothly, so that's cool. And you can go on top, of course. Pretty cool. Pretty cool, I think. What do you think? I think we have something. Of course, we need better models and stuff, and we need to make some cool levels. But I think we have something. And we can work on that. And throw that. Woo! Movements looks nice. Thanks. It's a simple controller, simple third-person controller, but I think it works fine. So yeah, that was it. That was my stream for today. Remember again, you can find me on Twitch if you want. I'll be there tomorrow, working on the same game, I think. I will be there at 4 p.m. UTC. I will be streaming that for about 3 hours, I think. Nope, these models dope. Yeah, true, the models are top notch. I'd love to make a small characters that with some animations and stuff. I've been doing Blender for a while, but it's been a while. I need to go back to Blender a bit to do some modeling. Just put some Minecraft texture and done. You're right. You're right. Guys, don't forget to check out the GoGodot Jam website if you want. You can get some merch, you can do donations, and see the other events. Every links are in the description.
And Cartuna is now following.
And that's a bit unfortunate, because what you saw right now was a Twitch alert, because someone just subbed on Twitch. I forgot to turn them off during the stream on YouTube. So thanks for the follow on Twitch. That's cool. I'm gonna go do some flips now. I hope that you find this interesting. You can also find the link to my game, Dashpong, that I'm currently working on in the description below. I will be releasing a demo soon, so you will be able to play it, and that is really cool. Thanks again for joining me tonight. It was really cool. I hope you had fun, and I will see you probably soon. Bye everyone. Bye.